Lesson 3-2, Solving Inequalities Using Addition or Subtraction. All right, in today's lesson, we'll be using what we learned in our last lesson, or reviewing how to graph an inequality on a number line. So today we're just adding one more step and we're solving inequalities, just like we would solve an equation, and then graphing that solution on the number line. So, just as we use properties of equality when solving equations, we can use properties of inequality to solve an inequality. So for example, our first key concept is the addition property of inequality. So notice the word changed a little bit. So if I have an inequality A is greater than B, if I add C to both sides, it does not change my inequality. So I can add something to both sides. In a couple slides, we'll talk about how we can also subtract something from both sides. So the inequality does not change at all. So let's use this to solve our first inequality. X minus 15 is greater than negative 12. So the only thing that's changed is it's no longer an equation. We have an inequality symbol. All right, well, I'm going to isolate my variable by using an inverse operation. I'm going to add 15 to both sides of my inequality. And when I do that, I get X is greater than, so the sign stays the same, and I get positive 3. So when you're answering these problems, you want this portion of it, the inequality, X is greater than 3, and you want a graph. So I'm going to open circle at 3 and draw an arrow to the right. So you need both parts. All right, in the second example, and the got it down here, n minus 5 is less than negative 3. Inverse operations, add 5 to both sides. I have n, is less than, the 5's cancel, negative 3 plus 5 is 2. So n is less than 2, and then I want to show that by graphing, open circle, less than. All right. In the next example here, we're going to talk about how you can check your answers, just like you can with an equation. So if this was our starting inequality, 10 is greater than or equal to x minus 3. We solve it as normal, so we're going to add 3 to both sides. That's the addition property of inequality. My 3's are gone, so I have just x. My signs stayed the same. 10 plus 3 is 13. So 13 is greater than or equal to x. I graph it, close circle at 13, shade or draw my arrow to the left because x is actually less than or equal to 13. Now let's see, we want to know if we graph the right solution. So let's pick one. We can pick 13. If I put 13 back into my inequality, I use an equal sign because it could equal, and that's the point we're at. Does x equal 13? Does that work? When I put 13 in, I have 10 equals 10, and yes, that does work. If I choose another point, say I choose this point, 12. So I put 12 in. 12 minus 3 is 9. 9 is in fact less than or equal to 10. So that works. So that's one way to check if you drew your arrow the correct direction, left or right. You can just plug in a point from that side and see if it works in your inequality. All right. Here's the subtraction property of inequality. Pretty self-explanatory. I can subtract something from one side as long as I do it to both sides. So we'll use that in an example. T plus 6 is greater than negative 4. I want to isolate t, so I'm going to subtract 6 from both sides. I have t is bigger than negative 10, so I need that as part of my answer. I'm also going to do an open circle at negative 10 and shade all the solutions greater. My second example, subtract 12 from both sides. My pen froze. There we go. Negative 13 is greater than or equal to y. So I'm going to shade. Oh, this one doesn't have negative 13, so here it is. Shade, close circle on negative 13. Y is less than, so my arrow would actually point that way. 0, negative 13, close circle, arrow that way. The last example is just writing and solving an inequality. So read the problem first and decide which inequality symbol you'll need. The hard drive on your computer, so the storage, has a capacity of 120 gigabytes. So that's probably going to be my total number. You have used 85 gigabytes already, but you want to save some home videos. What are the possible sizes of the home video collection you can save? So I have two things. It's going to be added together because it's all storage space. I've already used 85 gigabytes. Here's my variable x. X stands for home video space. I don't know how much of it. I can't go over 120, but I could be less. So all of this added up should be less than or equal to 120. So you have to think about what symbol you're going to use. So now to solve it, I will just subtract 85 from both sides, and I get 35. So x is got to be less than or equal to 35 gigabytes. Let's do one more example quick. A club has a goal to sell at least 25 plants. At least 25. At least means greater than or equal to. Club members sell 8 plants on Wednesday, 9 plants on Thursday. What are the possible numbers of plants the club can sell on Friday to meet their goal? So 8 on Wednesday, 9 on Thursday, and then we don't know how many they sell on Friday. So number sold on Friday if you're defining your variable. We say at least because we could go over 25, but we do equal to because we want to meet 25 at least. So this equals 17 plus x, greater than or equal to 25. If I subtract 17, x is greater than or equal to 8. So at least 8 plants on Friday. All right, that is the end of our lesson, and it brings us to our lesson check. Please solve each inequality. And number 5, you are writing your own inequality and solving.